Hello ladies and gentlemen, here is a video of another project. But wait, what is this and why am I even talking and making a video about it? And why did it took a whole year to mark this complete? And why did I change the architecture midway through? And did I learn a new language to build this project? Of course I did. And finally this bad boy is running. Of course, after changing the architecture, I must say it. Finally, this good boy is running. Anyways, let's dive in and learn more. Let me introduce you to this good boy, CAAS, Compute as a Service, or I can also say it Container as a Service. Let's see what it can do before I start the story about this project. Well, I will also provide the link to this project, a hosted link where you can go and try it for yourself. We'll talk about this architecture later on, but let's start by trying the demo. Try the demo, it will redirect you to log in with one of your Google account. And since I already have an account on this platform, it did not ask me for getting started, but you will see a page where it says getting started and pick a username for it. Straightforward, and then you will be at this page. So if you know AWS, it is very similar to that. It allows you to create compute and host your application into it. But it is fundamentally different. It doesn't create a virtual machine. Instead, it creates containers where you can SSH and host your application, install packages and whatever you want to do in that. You can do it. So let's start with creating a container. So before you create a container, you must have a SSH key. Of course, you want to SSH into it. So go to your account section, create an SSH key. Let's call it test, and then it will create a SSH key for you, which you can later on download. And then you can see that SSH key over here, test and main. So let's go to containers. And of course, you can see a maximum of 2 containers allowed per user, and all containers will be deleted after 30 minutes. Of course, this is a demo. I don't want everything to keep running forever. So let's start. Add container, name it my first container, VPC default SSH key. Let's use main because I have already downloaded it. Create, and then you will see a notification container scheduled successfully. So in few seconds you will see IP address on this instance, and you can easily SSH into it and host application. There you go, you have the public IP address and SSH port. Let's now SSH into it. You can just click this button and copy the SSH command, go to your terminal. Now will be inside download where I have my SSH keys. I will paste the command and path to my SSH key, which is main.pim. Yeah, okay. Enter, yes, and I'm inside that instance. Now I can do sudo apt update. Now there you see you have an instance where you can host your application. Now it has another feature of inbound rules. Now you don't want the hassle to create a domain name, point it there and host application, do all those hassles. You just want a simple container, or I would say simple instance where you can host your application very quickly. So here inbound rules allows you to use the pre-existing one of the domain name to host your application. For example, let's name it my nginx domain name. Let's say it what do I say, YT demo, of course. And now your application port number, so let's say 80. Our nginx will run at 80. You can choose anything, for example 3000, but let's just use 80 for now. And now it is added successfully. Now you see we have a domain name which can point directly to our instance port number 80. So now let's run something on our port 80. For example, okay, let's just open it and see we do not have anything. Okay, all right. Now sudo apt install nginx, easy peasy. Start nginx, also easy peasy, done. Now our nginx is running. So now we should see our nginx. Wow, do you see how easy it is? Create a container, create an inbound rule, host whatever you want, and there you go, you have a website to test. How easy it is. And of course you can create more than one inbound rule. For example, on port 80 you want this URL, and port 3000 you want something else. You can do that, of course. So this was the basic idea of this project. And of course the backend infrastructure is using containers, and you are now inside a container. This is a container. So if I open htop, you can see this is a container. Now I have not limited the amount of RAM and CPU for this container, but later on I may do it. But yeah, there you go, you have a system running and you can use it. You can create multiple of it. of course within the limit. Now congratulations, you might be the first person to know about this project, and you are the first person to maybe try and know how to use it. Congratulations. Anyways, more than this, the interesting part is what is the architecture of this thing, why did it took me a year, and yeah, the story of this project. Well, the idea of creating this project popped up when I was making this video and I was learning about Docker and in depth of how it works. And I thought, why not use Docker as a main infrastructure to create an SSH and host your application as if you do into a normal virtual machine. This is the GitHub repository of that project, which is of course open source. And I started it almost a year ago in December 24, let's say 25, and now it's 2026, January 2026. I started it a year back, but it technically did not took me a whole year to build. I was not building the whole year. There was some gap in between when I was doing my semester exams and other things as well. And I was also researching about how I can make this architecture more simpler and easy to deploy with, of course, less cost, and was also researching on SSH proxies, how can I make it easy, system containers, Docker. So yeah, I started it with a very simple mindset: create a container and host application and give it to the user to SSH and log in into it. But little did I know that this project was going to be a huge project, and I wanted it to be very scalable. So this old architecture was the architecture that I decided in the first place. So this was a whole scalable architecture with proper scalable infrastructure, multiple Docker hosts, and task orchestration. Let's see brief about the old architecture that I was thinking. Of course, this is not the new architecture. Here I was using SSH proxy to forward the SSH request to Docker host where the containers were running, and the SSH proxy was present to hide the infrastructure and IP address of the Docker host. And then clients as an user can go to main application, which was the website, and the WebSocket backend was there to allow you to directly interact and SSH into your instance through your web browser. The main application website allows you to create infrastructure through infrastructure backend. The request for infrastructure goes to this backend and it creates all the infrastructure and required parts on the Docker host. And to make this all asynchronous and scalable, I used task orchestration architecture. I pushed it to a queue, multiple queues and multiple orchestration, and then it will be done on multiple nodes. It was a complete scalable infrastructure. And of course this SSH proxy, so this was used to proxy the SSH request. Not a very huge thing. And remember when I told I learned a new language? Yes, I learned Golang during the project because I had to build that task orchestration. I did not knew about the language, but I knew that it is very easy to implement concurrency in Golang, and that was the main key for me. So I started learning it. It took me maybe few weeks. I learned the basic and tried it from very basic to a decent level, and I started building the whole orchestrator. So it took few weeks, I would say. But why did I shift to the another architecture? Wasn't it all right and scalable? Yeah, it was, but I was broke. I did not had all of the money to host this all infrastructure on cloud and keep it running while I do not have any user and any paying customers. So yeah, it doesn't make sense. So that's why I shifted this whole architecture into a new architecture so that I can keep it hosting and show it in my portfolio, because it is not a bad project. It is a good project to showcase your skills. So I wanted it to be running and to be present in my portfolio. So that's when I changed the architecture. Now the current website and the current deployment of it is running on the new architect, which leverages AWS. Yeah, I wanted to use free services provided by AWS to reduce my own cost of infrastructure, of course. So this is the new architecture. It looks complicated, but it is fairly simple, and of course it uses AWS things. For example, this web application has a database to store, of course, data, and multiple queues and Lambda actions to create containers. And this time around I was using Incus as container host, because Incus is another container platform which also allows you to manage system container and virtual machines as well. But for this I'm just using it as the container host. So now any request coming for container will go into a queue, then into a Lambda. The Lambda will asynchronously create the container and user will be able to SSH into this incus container. I removed the SSH proxy because it was of course adding complexity, and I wanted it to be simple to start and show it running. And user domain, yeah, the first demonstration that I showed where you can create inbound rule and you got a whole URL to host your application, that's happening through a reverse proxy. User domain app will go to a reverse proxy then into their container. So very simple. And the auto delete functionality is provided by this part, which is event bridge. The schedule created in an event bridge of AWS will trigger after 30 minutes. Pretty simple. It will trigger the delete function and it will delete the infrastructure after 30 minutes. Of course, this is the basic idea of the new architecture, and here it is running. Yep, that's pretty much it. If you have any question, you can comment down below. And as an ending note, this is not my final year project. I'm about to graduate from college and I have something different to show for final year project. So to keep up, subscribe and see you in the next one. Keep watching.